We're given capital F of x, y, z is a vector field. We want to show if it's conservative or not, and if it is conservative, we want to find a potential function. So each one of these, we need to take the partial derivative with respect to x, y, and z. So the first check is taking the partial of f1 with respect to y, setting it equal to partial of f2 with respect to x, etc. So we take first f1 with respect to y and f2 with respect to x. We see that the derivatives are both 2x. We move on to f1 with respect to z and f3 with respect to x. Those are both 0. Finally, we take the derivative of f2 with respect to z and f3 with respect to y and see that they're both 1. So because the equalities hold, we say that capital of f of x, y, z is conservative. Now we want to find a potential function. So each one of these components is going to be the partial of f with respect to x, y, and z. So we're going to set those equal to each other. So first we set the partial of f with respect to x equal to 2xy. We're going to integrate with respect to x and get x squared y plus a constant. Because we're integrating with respect to x, the constant is a function of y and z. So we'll call that g of yz. Next we move to partial of f with respect to y. That's equal to x squared plus z. Integrating with respect to y, we get x squared y plus yz plus a function of x and z. Moving on to partial of f with respect to z is equal to y plus e to the z. Integrating with respect to z, we get yz plus e to the z plus a function of x and y. So now we do a comparison. So we look at all of these three f of x, y, z's. We see that they both have x squared y, but this last one does not have x squared y, but it has a function that depends on x and y. So this j of xy has to be x squared y. Now this second f of x, y, z has yz, and so that this one also has yz, but the first one doesn't have yz, but it has a function g of yz, so this clearly has to be yz. And then finally we have e to the z. Well, e to the z is also a function of z, so this is also plus e to the z. And then h of x of z, well, e to the z is not a function of x, but it's a function of z, so you can also write this as just e to the z. And then finally, you could just add a constant. So putting this together, we have our potential function as x squared y plus yz plus e to the z plus c.